Let's look at this exercise, confidence interval on the difference between two means. So in the class, we talk about 4 cases. And let's look at this problem, see what case it should be. So 2 catalysts are being analyzed to determine how they affect the mean yield of a chemical process. So specifically, catalyst 1 is currently in use, but catalyst 2 is acceptable. So since catalyst 2 is cheaper, so if it should be adopted providing it does not change the process yield. Now a test is run in the pilot plant and results in the data shown in the table below. Is there any differences between the mean yields? Use alpha equals to 0.05 and assume equal variances. So if we look at the 4 cases, so the first case is population variances are known. So in the problem we just discussed, we don't know the population variance, the sigma 1 or sigma 2 are not given. So we can only compute the sample variance. So case 2, population variance are unknown and assume equal population variances of sample 1 and sample 2. So this is exactly the case that we are dealing with. We are assuming equal variances. Okay. We also have a third case. Population variances are unknown, and we assume unequal variances. And the fourth case is paired observation. So in this problem, we are going to use case 2. Because population variances are unknown, we have to use the sample variance and the sample standard deviation to replace the population variance and the standard deviation. So in this case, we are going to use the t-distribution. So this will be the confidence interval computation equation. Now let's get back. Let's use that equation, and we need to get sample mean and sample variance. So those are the observation number. So of course, catalyst 1, we have 8 observations. Catalyst 2, we also have 8 observations. Then we calculate the sample mean x1 bar and sample mean sample standard deviation S1. This is for the sample 2. And we assume equal variance. So this will be, let's put the equation here. So mu1 minus mu2 will be less than x1 bar minus x2 bar. But we plus t alpha over 2 n1 plus n2 minus 2, then we use the pooled variance or the standard deviation estimate. And because we assume equal variance, so this will be 1 over n1 plus 1 over n2. And n1 and 2, both of them equals to 8, greater than x1 bar minus x2 bar. And here we're going to use minus t alpha over 2, n1 plus n2 minus 2. Then we also have, similarly, we have SP, and then 1 over n1 plus 1 over n2. Let's write it a little bit better here. So this will be less than. Now, let's get, we know x1 bar, mu1 minus mu2. This will be 92.255 minus 92.733, and then plus T alpha over 2, because alpha equals to, here, alpha equals to 0.05. So this will be T 0.025, and the degree of freedom N1 is 8, N2 is 8, so 16 minus 2, so this will be 14. And SP, we need to compute SP. We also know this will be 1 over 8 plus 1 over 8. Okay. So greater than, this will be, similarly, we can put it on the left-hand side, and 255 minus 92.733, and then minus T 0.02514, and then we have SP, and then this is a square root of 1 over 8. So this 2 over 8. So this will be, in total, this will be 2 over 8. So 1/2. So because the square root of 1 over 4, right? So this part will be 1/2. Now we need to get SP first. SP is the pooled variance. So pooled variance, the SP is standard deviation. SP squared is the pooled variance. So this will be N1 minus 1 S1 squared plus N2 minus 1 S2 squared over N1 plus N2 minus 2. So this will equals to 7 times 2.39, right? This is a standard deviation. And plus 7 times 2.98 squared divided by 14. So this will equals to 7.30. So in this way, we got this part. This is 7.3. Okay, now we need to get T 0.02514. What is this critical value? Let's go to the T table. Let's have a look at the T table. T table is right here. 0.025, 0.025, 14, 14. It's right here. 14, right? So is it right here? Yes. So this is intersection. 2.15. So this will be 2.145. So 2.145. And then we put this number 2.145 here and 7.3 here. And then we plug in those numbers. We got mu1 minus mu2 is less than 2.4177 and greater than minus 3.3738. So this confidence interval, 0 is part of this confidence interval. So we do not have this confidence interval include 0. So we do not have strong evidence to conclude that catalyst 2 actually is, results in a mean yield that differs from the mean yield when catalyst 1 is used. So there is no significant difference under the significant level 5%.